Let's sketch this graph. So this, again, is a classic problem. It's almost identical to the one we've just seen. Let's think very carefully about what this looks like. So y, or maybe I should say x squared over x. It takes different values, doesn't it, right? Depending on what x is. Of course, right? So if x is not equal to 0, then this is just a law of exponents, right? I mean, it's just factoring off. So this just gives you x, of course, right? X squared over x. However, and this is the subtlety in this problem, if x is equal to 0, this doesn't make sense. It's undefined. So if this is f of x, let's say, the function you're dealing with is this rather strange function which is piecewise defined, really, and it's just x if x is not equal to 0, and it's undefined if x is equal to 0. So really all we've got to do is graph y is equal to x and then just remove a point at 0. So that's super weird, right? So this tells you the graph is going to be, well, y is equal to x is a straight line through 0, or the origin of slope 1, so it looks like that. But now, of course, we're going to remove a point. I can't have 0, so let's really exaggerate it with that point there missing. It's a bit of a weird way of drawing it, but that is this graph. So we're only missing one point, right? It's not literally that circle. I'm just really exaggerating the point. There's a hole at that position. So kind of neat, right? It's a pretty subtle example. It's a classic kind of university level example where if you just blindly do algebra, you can really miss kind of important details. So even though x squared over x algebraically simplified is x, that only works if x is non-zero. If x is 0, it doesn't make any sense. So as a function, things are a little bit more delicate.